All right, and welcome back to another live stream of some Proteus development. Again, if you want to get any more information, you can always go to owensd.io and just click the Proteus link up at the top, and it gives you a little summary of the basic idea of what's going on here. So last time, we got a little bit of things going. I need to close my Twitch channel. It's echoing. Alright. Okay, so I made my fonts a little bit bigger, and I fixed the annoying problem that I was having with the file not being saved when I built. So hopefully I don't run into any more lovely issues with that. So we're going to go ahead and open up source main over here. Let's just see what we had going before. So let's go ahead and go to build. Just make sure everything's working. I just set up a new machine. So that's weird. What's going on? Oh, whoa, okay. That's better. All right, bin protsy tests basic. Okay. All right, yeah. So we got all of our basic set of tokens out. So now we need to start turning this into something that's going to be actually a little more structured. Yeah, so what do we want to do here? I think what we want to do is now start building up our basic AST. So if you don't know what AST is, basically it's an abstract syntax tree. It's basically just a structured representation of your code that should be a completely valid representation in your language definition. So Swift actually gives you the ability to dump an AST, right? So let's see what Swift does. Up here, yeah. So let's see what Swift dumps for our program. Let's actually run SDK. Is it SDK Mac OS X? Swift C source everything.swift. And let's do dump AST. No. Alright, so let's say it. Oh. Right. Let's actually pass it into the Swift compiler. Alright, yeah, so this is just one representation. It's like closure. What's going on? So eventually we'll build up to something like this. Wow, this is a lot of stuff. Okay, so they got here source file, import foundation, declaration, top level code, brace statement, binding path. So this is the main file right here. You can see it's going through and parsing. Yeah, so they have brace statement. That's interesting. They have a string path. Yeah, so the type of this path is string. That makes sense. Pattern named. Subscript string, location, range, array, subscript, member of. Yeah, so got a lot of stuff. We're not going to have anything near that advanced as we start. We're going to go ahead and make a much simpler version. So if we run our program, what we want to do is basically just start grouping these things together. So this is going to get turned into, well, actually this right here is going to get turned into one valid representation inside of our AST. Then we're going to turn this whole thing into another valid representation in our AST, and then we should be done. So let's go ahead and get those two things working. Let's see what we want to do with this. I think we just want, let's just create something called AST. Oh, actually, before we get started on that, there was, last time, I was doing this thing with the UTF components because we didn't have, I didn't think there was a version of character is member, but it was actually pointed out that there is one. And so I did not know about this. We'll look at NS character set. Documentation, class reference. There's actually a long character is member down here that we should be able to use instead. So let's make that change real quick, just so we can get this kind of hacky thing going out of here. So well, right, I think, I don't know if it'll work with that new char. Let's see if it does. Member. Right. So if set is that, then is member. Actually, we don't need to do that, right? We just need to return. Alright, so expected is a UTF 32 char. So I wonder if, what is a UTF-32 char though? A UN-32. So what's a character then? A character is just a unichar. Oh, oops. Well, maybe we'll keep what we have for now. Alright, let's just look for string then. Alright, strings. Okay. What? Unicode scalars. I mean, I can convert it to a string and then use the Unicode scalars instead, which will group the whole thing as one, which is fine. maybe I'll just do that. I actually want the, is this really the documentation? Alright. That's right, I was thinking that there was another. Alright, well, let's just do that then. Let's at least group them so that there are UTF-32 components. Oops. Goodness gracious. Is that right? What? No. I forgot to actually delete this line. No UTF? I guess maybe it's just Unicode scalars. No. UTF char. Alright. I'll have to do some research maybe to figure that out. There is some conversion between those types, but I just don't want to deal with it right now. So we'll just keep this. Alright, let's go back to our AST. So how do we want to think about this? These are basically like statement level stuff. So we're going to go ahead and create a statement AST. Right? I mean, it's probably going to be a protocol or something like that. And then we're going to create an import statement. Yeah, I might want to group these into like a namespace or something, so I don't have to just write AST every time. But by namespace, I mean like an enum. Alright, so import statement AST, and an import statement is going to basically end up having two things. Right, it's going to have the import token. That's going to be one of our tokens, and it's going to have so for now, we're going to have just a single import. Alright, so when we go and create the import statement AST, we'll assign those two things through our parse. Yeah. Alright, let's see how this is shipping up here. So we have our Lexer, we're going to call next on that. So our parser itself, alright, so we're going to need to create a parser. I'm just going to call it parser. What we're going to want to do is pass in the file name. For now, we're just going to deal with the single file. want to give it a file name. Yeah, I think I want a file name here. I'm just trying to think, do I just want to do strings or do I want to set a file names? I think I want to do a set of file names because then we can do some more interesting things on those file names later. So it's just the path. Okay. All right, and then I think maybe we just want to do call parser dot. So we can either give back the entire parsed set of data. So let's just do that. So we'll do let tokens parser.parse, and we'll just have that return back our set of tokens. Okay, and then for token in tokens, let's just print them out. Yeah. I think that's how we're going to want to use it for now. So let's go ahead and get that compiling. All right, so we're going to have a file name. This is going to return back a set of AST items. So an array of AST, I guess. Okay, so this implies we have some sort of per type of AST. Just for now, let's just do that. All right. We'll get rid of that. Okay. I have a GitHub thing in here again. What? How does that keep getting in there? Undo. Build. I don't. Okay. Okay, so what we're going to do is come over here. I think we actually just want to go ahead and I think we're going to end up doing that, right? So the file name, actually we don't want it in, let's do it in parse. Swift style is this way. I really don't get those flat up against there. Okay, so what we're going to do is we're going to come in here, and this is actually going to be file name. And we're going to create the content. We're going to go create a scanner. Then we're going to create our lexer from the scanner. Then we're going to have our token loop. And then we're going to go through and create all our tokens. So basically what we want to do here is, let's just go ahead and create something else right here. function tokenize, and we'll just return back a set of tokens. Yeah. Which is essentially just going to call next. So our tokens equals an array of tokens. I guess we're always going to return. Let's just always return that. All right. And so let's see here. While let token equals tokens period append token. Yeah. What's the problem? Oh. Immutable tokens never used, blah, blah, blah. Errors. Oh. Right. So this guy throws, all right, we'll just, for now, this is one thing that's, these throws inside of Swift are actually pretty pervasive. So once you have one at a low level in your calls stack, you're most likely going to need to like bubble it all the way back up or just handle it somehow. I don't have a great way of handling it here right now. I mean, I could return back an empty AST, but we'll probably just want to do some better error handling later. So that's fine. Parse can fail. All right, so now we just have that warning. Okay, great. So now we go run our program. An infinite loop. That's right, because our stupid next. All right. So I think what I want to do, I want to update this so that the next time through, after an end of file, we return nil. Yeah, that way I don't have to like try to special case it over here. Alright, so let's see what the next is doing. Alright, so scanner next, that's just gonna grab the things, return end of file. Okay. And do I need, I'm gonna need to mark it now. This is kind of ugly. Oops. Alright, so self.end of file. Okay, so if self.end of file. Alright. There we go. That's pretty ugly. Scanner.next equals nil. Can I probably just use current? I don't know. Where's current being set? Where is current being used? Yeah, it's not being. There's a. If I recall peak on this thing, this isn't going to work. Okay, so let's fix that. And in doing so, we're going to go ahead and get rid of that too. Oops. Okay, so what I'm actually going to do is I'm just going to nest this thing in another function. So function work, I don't know. Right, it's actually going to be the thing that does everything. So come all the way down to there. All right, so now, so what this is going to do is going to allow us to basically keep all of our returns in place, cache the current token, and return it. So this should actually really be returning current. All right, and so then we should say self.current. And so up here, so when we return the end of file, we're going to say this is end of file, return whatever we just had there. That's great. The next time through, scanner.next is going to equal new, and we're going to say it's still the end of file, and it's kind of bogus, right? Yeah, if our current is on the end of file, when I call next, I want to go ahead and, all right. So current is a token that I have to do switch on, right? Oh, I know I can do if let. Oh, maybe I can do if let. So let's go ahead and actually collapse this back down. Oops. All right, so if self.current equals is it if let case? I don't remember the new syntax here. If let case self.current is .end of file, do something else, do something else. I don't think that's right. All right, let's go to the old Swift docs. Maybe it's in this if let case. No. If case, maybe. All right, so it's not there. goodness, where is it at? Could be in control flow. Oh. No. Alright, let's look here. Oh my goodness. What is the new syntax? I swear it was if let case. Oh, Swift. How I read you. Alright, so if let case Swift. Yeah? If let, that's the optional. What is it? If let case. I may have to fall back to the switch statement until I remember how to do this and look it up later. Oh, is this it? No. Alright, whatever. Oh, da-da-da-da-da. Case dot, and the file. Defaults. We're going to self.current. And the file is not power token. Oh, it would help if I unwrapped it and then used it. Alright, this of course won't work What was the errors? Missing a return. Why can't I go down to the next one? Line 146. Okay. So if our current one is in a file, go ahead and set it to nil. So the interesting thing is the first time through current's going to be nil. So we don't want to bail out then. Let's see here. First time through. Well, we could do this. That's really ugly. If I could remember the case statement for this, I think we can make that cleaner. But switch must be exhaustive. Of course it must. Let's just do this. And we'll come back later and make this better. Okay. Now we are able to actually run our code properly. Okay. So that was a lot of work for nothing. Okay. So we got our tokens doing something now. We can actually utilize our peak function, but now we actually need to go and do something interesting. Okay. So in our parse, what we're going to do is we're going to get the tokens. Let's just make sure we're actually getting some tokens now. Before we get too far ahead of ourselves. Okay, great. So we have all of our tokens, end of file, and we got the nicer behavior that we wanted. This code still sucks big time, and then that's okay. So what we're going to do is we're going to go through and just start reading through these. And so I'm going to check this first one, and if it matches, well, I mean, let's just start writing the really hacky way, right? Which is, all right, so for, now we don't even want to loop. What we want to do is get the current token, get the first token. Tokens.first. So that's going to give us an optional if all right. So right now the only check is it's going to, I really need to learn that if case statement. This is going to suck to do this every freaking time. So really what I'm going to do is I'm going to look up and see if we have a keyword. If we have a keyword, then in our language, most of the time, when we have a keyword, we actually have a declaration. And so we can kind of treat these imports as a declaration, just like we can treat that as a declaration, especially if we're going to support a syntax that might look like, well, if we cat out our file, actually, over here, we just edit it up. So our import is going to look like this. If we might do something like this. So yeah. All right, let's go look it up. Maybe we can find it in here. If case blah equals that value. Okay. If equals self.current. Now, I don't know if that'll unwrap it or not. Match using an optional pattern. Some optional. Yeah. I have a mixture though. Well, let's see. If expected expression. Oh my goodness. Edit. Okay. So, that's weird. Oh, that's the wrong one. Oh, goodness gracious. Okay. Yep. Okay. If case, that's not going to work, right? All right. So it'll magically unbox it for us. Perfect. All right, so if that's the case, if it's the end of the file, then we're going to do self.current equals nil. Otherwise, go on and do our work. Save the current. All right. Yay. Okay, that's still working. Perfect. Okay, so if case token here then. Oops. If case dot keyword. Plus token. That's right. This syntax is vaguely familiar. I'm remembering a little bit because I always thought it was weird that you're basically doing this pseudo assignment on the right hand side of these if statements. Okay. So then, here we would process all of our keywords to see if we actually want to do something with this. So we're going to cheat right now. Yeah, just a hoodie. It's chilly down here. Okay. Not too long. Not much hair up there either. Okay. So we have a keyword. So if our keyword equals import, I'll probably want to actually like start storing those out somewhere, but then we're going to go ahead and create, actually then we're going to go ahead and want to do our parse. So this is kind of where we're doing this is where we're going to start doing our recursive descent. We've noticed we hit something. This import is actually going to be a series of steps that we're going to go do some more. Oops. Some more stuff. And so in this case, it's not too bad, but if we had an expression that was maybe something like this, too, we're going to want to actually go through and grab all of that stuff. All right. So we're going to set our we'll just get our results, and AST is going to be parse import. And we probably want to pass in all right, so let's do our lexer. And instead of doing this, we'll do that. Oops. If you're new to my stream and you're wondering why I'm fumbling so much in Vim, I don't know it very well. Okay, so while token, lexer knows that. Okay. Yeah, this will give us the ability to do the same stall concept that we did when we did our scanner. And I'll let this parse function actually do its own thing. Okay, so down here, it's going to return some sort of AST. And we probably just want to go ahead and throw an error. And we'll probably want to add a bunch of error information that way. So let's do try parse import. Parse already throws, so that's great. Okay, and so up here, we said we were going to create a listing of ASTs. So let's just do parse equals an empty array. There's a question if I typically use Vim. No. So I usually use Xcode when I'm coding on a Mac, but I've been pretty frustrated with Xcode lately. And so going back to my, not even really my roots, I never really use Vim that much, but going back to an editor that I can get free of the Xcode bugs. At work I usually use Visual Studio when I work on Windows boxes. Alright, so we got our parse, and at the end of this we're just going to return parsed. And so what we're going to do is just go ahead and parse.append this AST. Okay. Alright, so import AST. Obviously we're going to need to make this an AST of sorts. So I think what we're going to do is go ahead and make these in a enum, and we're going to call these statements for now. Inside here we're going to have an import statement. And it's going to have two pieces of information. It's going to have our keyword, And it's going to have our value, which is going to be the standard lib thing. Okay. All right, so I'm doing that because I need to actually be able to return these things. Structs are not inheritable. And then you can't actually say you want an array of a certain protocol. So that kind of forces me then to use classes and inheritance, and I just don't want to do that. Our statements are going to be well known. They're going to be a unique set of items that are not going to change over time. So we're going to go and do that. So what we're going to do is replace AST with statement. Okay. And then we're actually going to come up here and do that S. Okay. Unresolved identifier token. Union case keyword. So the Lexer returns back a token, and a token has keyword. Oh yeah, it has these. That's right. That's another annoying thing about these associated data ones. If you don't do them all right. No, that's not the issue. Enum case keyword not found in type statement. Yes, I know it's not a Parse statement. Why do you think it is? Token is not a statement. Oh, well. Shouldn't the error be there's no tokens? Why? That seems like it should be the compiler error. That there's no tokens. What the? That's an interesting bug. There clearly is no tokens, but Swift thinks there is? Alright, so every time I run into one of these little things, I always zip up my project and see if I need to file a bug report. Extra tokens bug. Okay, so that was weird. So we actually want to get rid of that. Get rid of that. Okay, so let's see if it's happy now. Alright, perfect. Hey, our missing return in a function expected to return statement. Line 207. Oh, yeah, we haven't gotten down to implement that yet. Okay, so what we're going to do is, so this is where it kind of gets a little bit weird. I've already done a check up here to see if we have a keyword. We don't really want to necessarily assume that that's true, so we actually might want to, let's actually do this. So what I'm going to do is actually just go ahead and call parse import, and if it doesn't have one, then we'll go ahead and return nil, and then we just won't do anything, and then we can move on to the next statement. That way we don't have those duplicated checks there. All right, so, and in that case, I think I still want to do the keyword for now. Let import statement be parse import. Oh, right. Okay. And so if we have one, this is actually not going to be a statement. Yeah, it's going to be a statement. If we have it, then let's go ahead and add it to our parsed. And then we'll go on and do some other stuff later. Okay. We don't use the keyword. That's correct. We don't anymore. Maybe. I'm gonna have to duplicate the keyword case again. Do I want to do that as well? Let's get rid of it. Right, so if case let keyword equals, it's going to equal flexor.next. All right, then if the keyword, actually I should be able to do, I wonder if I can do the where clause on that. I don't know if that's going to be any more readable. All right, then we're going to let the st be that. We're going to not call parse import because that's what we're doing. Otherwise, we return no. Okay, yep, we got an extra one up here. Where do you want me to use try? Try is for when we're going to throw. Okay. So now we have a keyword. Great. So now we want to look at our tokens. So I should have not. I should still print out my tokens maybe, just so we can see them better. But we're gonna have this import token, and now the next one that I'm gonna look at, we expect it to be an identifier, and if it's not an identifier, then it's going to be an error. I am going to need a try on my parse import if that's what you're talking about. Because of this throws. And if I do this, yeah, so maybe that's what you meant. Good catch. But why then? All right. God. Yeah, the try there makes it another optional. Yeah, no, I don't actually want the try question mark there. I want the error to bubble up through the parser because I want it to currently I want it to fail on the first one. So I do want the just normal try. The error I was getting with when I had the try question mark was that it's boxing this optional result. This if let only unbox that first one, and so I actually had to go one more deeper, but I don't want that, so it doesn't matter. So what we want to do is we want to get the next token here, and that's going to be lexer.next. Does that throw? I forget. Nope. Okay. So if let next token, right, in this case, if this happens to be nil, then we have an error. And so this is where we're going to start introducing our error messages. So for right now, I'm just going to make one basic error that we're just going to fill in a message for, and then we can actually add on proper error messages later. So case, message, invalid syntax. Right, and we'll have some string that'll be the message that we want to write. So in this case, I just want to throw error.invalid syntax. Expected identifier. Terribly unuseful error message. We don't even show the line number or anything like that, but that's okay for now. All right, so in this case, now we need to do our if case crap again. If case dot identifier, and then we have the identifier, land the line in the column. And it's going to equal the next token. All right, actually, if it's not, then we're also going to get an invalid case here. Don't worry, I put them up on YouTube if you want to watch them later. That way the whole world can watch me bumble through my code. So in this case, what we want to do is actually add this here as well. And so we're going to say that we're happy with this state, and we're going to return back a new import statement. So we're going to return back dot import. Import statement. Keyword is going to be keyword. The value is going to be our identifier. Okay. Let's get through our errors here. I like looking at this one better. All right, error enum case keyword not found on the type token. That's right. It's because next is optional. Use of a unidentified, I just can't spell. Oh. So right here. So that's actually a place where, so the error message in Swift right here, this is not a good error message. Use of unresolved identifier. You look at this and say, I have an identifier. What's your problem, Swift? The problem is you actually didn't introduce the keyword let over here instead. So we'll try to make better error messages than that. Okay. So we got one more error. It's ambiguous without more context. That's awesome. 209. This is ambiguous. The import statement with keyword token value. Oh, right. Yeah, that actually makes sense. I actually want this whole token. Ah, crap. Okay. Let keyword token let keyword token be the lexer.next. Okay. And so we're going to go ahead and, let's see here, delete to keyword token. Okay. If that's the case, then we're going to do let, identifier token equal lexer.next. Delete to identifier token, import stream, and then over here, yes, livecoding.tv requires, so the question is, why am I using Twitch over livecoding.tv? Livecoding TV requires Flash plugin for one. It also only allows you to upload your videos or stream your videos at 1.5 megabits, which is basically 13 something by 768. So the quality is lower. I'm streaming at 1080p, so I don't know if you can see it at that, but like the later when I go to the YouTube videos, I upload those at 1080p. Alright, so let's go ahead and build. We should be getting closer. In case identifier not timed with token. Oh, yep, it's just the same thing. Immutable token, yep. Next token. Oh, well, okay. Actually, yeah, we can delete that now. That goes to nowhere. And then we want to dedent that crap. There's probably a dedent command. I should probably learn it. That's still ambiguous. Why? Keyword is a token. These are tokens. Ow, these are optionals. Inside here, they are not optionals. Okay, so I can do a whole nother if let blah 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 crap. Let's just do that here, right? If let keyword token next. All right, so now we know it's that, so we don't have to do the optional in there. Then we can do if let here. Then we know it's not optional. All right, so we need to what do we need to do? We need to indent this. Okay, we need to indent this one. Yeah, and okay, there's that one. And then, all right. Wow, that's awesome. Okay, so Swift added this ability to basically put commas to kind of flatten this, but I don't think it works with this construct. So we're going to leave it as awesome as that. So so the basic thing that's going to happen is if we have an import keyword, then there's an expected next token that we want. In that case, if we don't get it, then we're going to throw an error. In the case that we don't actually have a import token for the keyword, then we want to return nil, which tells the callers for the parse import function that there is nothing found here. So let's make sure we put the throw on the right spot. All right, so if it equals import, we actually want to go ahead, I think we're just going to go ahead and throw that. So yeah. Right. So this says if the keyword is import. Okay. So now once we're inside this block, what we actually want to do is make sure that we get an error coming out here and that we don't actually end up just returning nil, because this is now an expected, like these two lines right here said, hey, yes, we are actually going to go look at import. And so now we want to make sure that the contents within here either returns a valid import statement to AST block or returns an error. And so I think we can just go ahead and get rid of this. Like we would want those if we were going to actually write better error messages, but right now we're not going to. All right, so if let identifier token, what just happened? All right, we got two warnings. Let's see what they are. Immutable token was never used. On line 195. Walnut token next. Interesting. Yeah, so this code isn't actually going to work. Could we use guards to clean that up a bit? Yes, somewhat. So if we use guards, we could do this. Guard let keyword token equals letter dot next. I'm actually going to use peak, and so this is what I was just talking about. The code. This code doesn't actually work. If we were to run this code, what's going to happen is we're going to get the next token, which would be the import here. Then we're going to call parse import, and parse import is going to go call next, which would be the standard lib identifier, which is not what we want. So we're going to have the parse import always call peak on that first one, because that is indeed this. So we're going to first get rid of this, because we're not actually going to use this. Okay, and then over here we can use guard. All right, so if that's the case, then we're going to return no. Right, because this is the case I was talking about. If peak is nil, then parse import should not throw an error. It should say we don't handle anything. All right, so that got rid of this. Now the next thing we want to do is, I don't know if we can use guard with if case statements. Let's find out. I'm pretty sure we can't. Actually, I'm almost 100% sure we can't, because I believe I logged a bug on this. But maybe I'm wrong. Let's try it out. And we definitely can't use the where clause. If that works, I'll be shocked. Else, just return no for now. I just want to see if this even compiles. 195 token optional can't be used as a Boolean test. So we have to do this to make that part happy. Alright, so maybe this is going to work, and it's just a spelling word problem. Oops. Oh my goodness. Oh wow. Did that actually work? Sweet. Okay. So, okay. Well, if this is the case, this is actually an error. Oops. Where am I at? Guard input. I'm really surprised this case statement worked. I swear this didn't work in the early beta, so maybe they actually got that working in the 7.0 GM build. So case let keyword token, where keyword equals import. Yep, so if we get that case where it's not import, oh no, we don't want to return, that's not an error. That just means we're not processing an import. Okay, I'm going to build that one more time. Yeah, that works. Sweet. So now we've gotten rid of this. Okay. All right, so let's do that. Guard case. Well, so, if we do a guard again here, I'm going to have to duplicate my throw multiple places. That's okay. Let's just see how this works. Let's see how this plays out. Actually, let's try the other one. Oops. Let's try the newer version of goodness gracious. There we go. Let's try the common one. So if let identifier token next. Right, because I need the token, otherwise I could do the optional there. Alright, so then we're going to delete that. If let identifier token next, comma case let identifier token. I don't think that's going to work. That doesn't seem to really clean it up anyways. We could guard that, maybe. Maybe we should. Let's see if that looks better. So if we guard case let identifier token equal lexer.next. Throw ML syntax expected identifier. Right. If next actually equals nil, like that's actually, it's going to be a bigger problem than the identifier, but that's fine. All right, so now we've gotten rid of that. Then we only have this guy left. So then we can do the same guard statement we had before. Or let's just keep this one as the if. Because if I don't, then I'm going to have the else clause throw an exception, and then I'll also have to have this throw. Right, because we've actually bailed now early on the two cases where parse import says, hey, ignore me, ignore the call to me. Then we're coming down in here, like this is the actual meat of, like this one is the, all right, we have an import keyword. Anything past this now is going to be an error. So guard token, throw an error, if case let identifier. Oh, I don't use this identifier anymore. What do I need this for? I don't need it at all. All I need to make sure is it's an actual identifier. Right, okay. So I do need it for that. And then we're gonna go ahead and copy this. And paste. Oh, seriously. Throw invalid syntax expected identifier. Oh, can't return the throw. Oh, what? Invalid syntax? Okay, type of expression is ambiguous without more context. Line 209. This line. It says this is, oh, right. Errors aren't typed. You can't just do that. Do I want to call that something better? Parse error? Whatever. Alright, same thing over here. Okay. Oh yeah, I've got to get rid of that let. Wow. Alright, that's a little bit better. It's got rid of most of our diamond code and flattened it all out. And these are going to be different error messages anyways when we actually get to really implementing it. So that I'm okay with that being duplicated code for right now. So if we come over here and actually run this thing, nothing should happen, right? Parsed token. Oh, that's right. I forgot that I actually added some stuff in here to source main Swift. I don't know why it opened in that buffer, because I was using that one for my parser. I'll do this one. Okay. Yeah, so I'm going through the parse token. So we parse the token, we have an import, and we have the identifier. So great. We have our first parse in there and working. So the next thing is, I think what I want to actually add into here, what are my keys? I think my keys are browns. It's the DOS keyboard 4. This one is the ultimate version. It doesn't have the keys printed on it. I would not do that again. I always forget, like, sometimes you'll see me trying to bounce back and forth between the end of the line because I need to hit shift dollar or shift caret, and yeah, I guess I have not memorized where those keys are efficiently. My accuracy rate is about 30%. But I like the keyboard. At work I have just the normal DOS 4 keyboard, and that works really well. Okay, so we got our parsing going. One thing, we had those terminals in our Lexer that we're coming through here, and so we should actually probably check that we have a terminal at the end of here as well. Otherwise, if we had import foundation, well, I guess I'm thinking, do I want to do that here or do I want to do it on the next statement? I think I would like to eat the terminal. Yeah. So let's do that. So in our Lexer, we should actually have a terminal statement next. If we don't have a terminal, that means we may have something like a comma or some other token or a parenthesis, and that parenthesis would be invalid. And we don't want to necessarily say, hey, this statement is correct until we actually see a terminal. Okay, so let's do that. So if case identifier, so instead of returning right here, all right, so I guess we'll do a guard, and we won't flatten it, right? If guard case identifier token else throw error dot invalid syntax. I don't even know what the error is right there. What is the error right here? It's the expected identifier. Okay. Then we're actually going to come down here, right? So there's going to be one more thing that we're going to need to check for. So guard case terminal, is that what it's called? Okay. Terminal equals lexer.next. And this time we don't actually care about that thing, so we can wrap it in the optional else throw error.invalid syntax. And we can say expected terminal token. Right, and the terminal is just what we use to denote the end of the line. It's kind of like semicolon injection. Okay, and so in that case, we actually can just return the valid import statement out the end. Yeah, that cleaned that up nice. I like that. I like that a lot. Yep, perfect. Okay, that's looking good. Oh man, how long have we been going? I need a timer. Is there a timer on this? An hour and a half. All right. I think that's probably gonna wrap it up for this stream. I wanted to try to keep the streams down to about an hour. So next time we'll come through here and we will fix up this parse a little bit more so that we can parse the rest of this basic file. Tests basic, so that we can get through here and get our print converted into our AST that we're going to be using. And then we're going to go write a rewriter that's going to take our AST that we've generated and create a C program and compile that. And we're going to say we have our first running program. So great. Thanks everyone for joining.